So we had just talked about the regular neutral situation for the Pacific, especially in the southern Pacific, and the southern oscillation. And that southern oscillation is necessary because over the course of a few years and a lot of upwelling, you pushed a lot of water toward the western Pacific and toward Indonesia. And in pushing that water, you pushed warm water over to the western Pacific and Indonesia. And now you have a low pressure system over western Indonesia with warm water that is convecting up and producing a surface low and storms in Indonesia. And that's fine. The thing that is unsustainable is the fact that you have a lot of water in western Indonesia and less water off of South America. That's an equilibrium that's got to be balanced. And you have a high pressure system off of Peru, and you have a low pressure system off of Indonesia. And that's got to be balanced as well for equilibrium. Well, El Nino is the reversal that brings the equilibrium. That equilibrium is not on a regular basis. It fluctuates between 5 and 7 years, and it can go a little longer or a little shorter than that as well. But it is definitely a means of stabilizing the equilibrium that has been building up in the neutral circumstance. Let's explain a little bit about the details of the change in equilibrium. The normal situation would be a low pressure area over Indonesia and a high pressure area over the Pacific around Peru. This El Nino reversal starts moving everything back, and now suddenly we have more water coursing toward Peru. That is suppressing the upwelling just by mass alone, suppressing the upwelling in that area. You see more warm water now off of Peru. And in doing so, and in moving all of this warm water that warms along the equator, suddenly now we have warm water off of Peru that is convecting and rising slow. And we have a surface low off of Peru as a result. Our equilibrium has happened in Indonesia, and now we've moved so many molecules out of the atmosphere that this atmosphere sinks and sinks down to replace those empty that empty vacuum, that empty cell where the molecules left from. This is called a subsidence or sinking inversion. It is bringing down warm air from the atmosphere, that sinking sky, warm and dry, surface high. That's what's happening here. It's called a subsidence inversion when you see it on a sounding. So we're trying to layer all the things you've been learning. This El Nino is the reversal. This El Nino impacts sea levels, sea surface temperatures, and sea pressures. This is a system that not only impacts temperature but also pressure. When it impacts temperature, it is known as an El Nino. When it impacts pressures, it is known as a southern oscillation. El Nino really impacts both. It's a little bit confusing, but what I'm saying to you is when you hear the word El Nino, you're generally thinking of what is a temperature and a pressure reversal, sometimes called an ENSO, El Nino Southern Oscillation. Okay, so in El Nino years, you might see in papers, scientific papers, you might see it referred to as ENSO, El Nino Southern Oscillation, when this is in effect. This usually goes on for 1 or 2 years. It can go on for more. It can just go on for 1 year. Often it's 2. And then we tend to go back in the equilibrium to the neutral situation again. So this is like a pendulum that swings, it swings back to the neutral situation. If you think of the gymnast that we were talking about, this is the gymnast who's hanging off of the parallel bars. You push her with the neutral a little too far, too much water in the Western Pacific, and she'll reverse back with El Nino, and then she'll come back to neutral again. This is a stable equilibrium, okay? That's why we learned all about equilibriums. The result of what you see in El Nino is far and wide. That's what we call the global circulation. As a result of this, warm water is heading into Peru. And you see it in the years of El Nino that Peru is hit by warm water, which really impacts their fishing industry in Peru. They have learned to get around it a bit, but it is still very, very impactful to the Peru fishing industry. When you erase that upwelling that was bringing so much good fishing up to the surface. In addition, it impacts our weather as well, because during an El Nino, this Pacific high off of California and this high off of Peru are weakened. They are weakened by this system heading into Peru, countering all the currents that are normally in place. That weakens the highs, and as a result of that, the high that normally sits off of our Pacific coast is not as forceful as it should be. It doesn't steer our subpolar jet. So our subpolar jet comes right in with cool and wet weather, especially during the winter time. This doesn't turn into a low. I disagree with the low that's there, but it certainly is not a powerful high during El Nino years. So the subtropical jet stream comes right on in with wet and cool air. I'll give you an example of it. Let me go. I thought I had a better example of it for you. Darn it. The Pineapple Express from Hawaii is a prime example of bringing in wet and cool conditions into the United States during El Nino years. I'll try to put that in next time. We gradually return back to neutral conditions and bring the cool upwelling up again and start this movement back toward Indonesia, reestablish the high pressure area over to the offshore of Peru, and the low pressure area in Indonesia. La Nina is when we got a little too far on the neutral side. We strengthened the neutral side a little too much. In this condition, the high becomes a very powerful high. The low becomes a very powerful low. The upwelling is really fierce, and the drive of water across the Pacific is heightened. This is an equilibrium situation that went a little too far out. It became a little bit less stable in La Nina. But La Nina is not the opposite of El Nino. La Nina is a strengthened normal. La Nina actually will pull the cold water across to the Western Pacific. There will be a lot of upwelling. You'll see it right here. And you'll see it right here as well. And this water will not warm up. It will be so much upwelling. It will not warm up as much as the water before on the equator. It will head over and bring cooler water over to Indonesia, as well as a lot of water. La Nina does really wreck a lot of the environments around it. It really impacts our climate as well. We may be heading into a La Nina now, still up for debate in NOAA as of July 2020. Not quite sure, but there are indications that we're heading into a La Nina. What will this mean for us? It means that this high will now be strengthened. It'll pull off more upwelling. It'll pull more cold water to the Western Pacific. In this high being strengthened, it will steer the subtropical jet, and that will steer into the United States, meaning warmer and wetter winters on La Nina years. So this is how it affects us a bit. This says here the southern branch of the polar jet. I am really saying that that is the subtropical jet instead. So I disagree with that slide. El Nino and La Nina have a neutral pattern and a positive and negative pattern. El Nino is really known as the positive side of the pattern for temperatures in degrees Celsius. El Nino is the warming of the positive side. There are quite a few neutral years, but this divides it into positives or negatives. These are the neutrals in here between the red and the blue. Not a great way to show you the neutrals, but it's what I've got. And this is the El Nino years, the La Nina years, and the neutral years. I hope that helps you understand a little bit more about how El Nino impacts temperature and pressure. Let's go on to some more oscillations.